Righto, well, good morning, everyone. And now you know who I am. Uh, I'm going to be talking to you today from beautiful Hideaway Bay in the Whitsundays and give you some idea of the path we've followed in the development of underwater visual fish counts over many years. Oop, oh, here we go. So I better start with a bit of a history of why I'm involved with fish counting, why I've been involved with fish counting. Well, I was actually born in England, and my parents emigrated to Australia as 10-pound poms when I was 18 months old and looking very cute, as you can see there in the photo. And remarkably, my first memories in this world are living in Alma Bay on Magnetic Island, where we spent 6 months in 1950 while my father was working at well, what's now Telstra in Townsville. He was an engineer there in charge of the whole North Queensland region. So we spent a fair bit of time on Magnetic Island. Oh, so that works now, sorry. And then my mother unfortunately turned out to be allergic to mosquitoes. So when I was 6 years old, we moved to New Zealand, and that's where I grew up. And there was a defined, can you see this photo? It's covered up on my screen. Oh, righto. Yes, we moved to New Zealand, but when I was 10 years old, we went to a beach and had a defining moment. I was messing around on a tiny little bit of sand between two rocks, and along the tide line, there was a lot of dead shells. And I picked up a handful of these and took them carefully home, laid them out on the table and sorted them all out and found that there were multiple species and they all looked different. A lot of them looked different and some were the same and some were different. And my father came along and looked at what I was doing and said, well, marine biologists know all about things like that. And so there and then at 10 years old, I decided that I was going to become a marine biologist and study things like shells and the sea. And in fact, I carried that to ridiculous lengths. By the time I was 12, I'd got hold of a university calendar and which spelt out all the courses and what you needed for different degrees. And I'd worked out my whole university course by the time I was 12, which I followed when I eventually went to university. And about the same time, my parents took me along to the movies to see a film by Hans Haas, who was a famous early underwater explorer, used oxygen rebreathers rather than scuba. And he had a film called Under the Red Sea, which I watched, enthralled, and there and then decided that I was not only going to become a marine biologist, but I was going to learn to dive and be a marine biologist studying things underwater with scuba. So I then found that the Auckland Underwater Club had meetings every month, and I went along to a meeting and found that they did courses where they trained you to dive. There was no such thing as PADI or NAUI or anything like that in those days, and it was just experienced divers teaching newcomers how to dive. And they had a night a week at what was called the tepid baths, these warm water enclosed swimming pool in Auckland. And I went along there 8 weeks in a row and learned all about
Good, how are you? Yeah,
theory and
good.
practice
I'm
of
returning your
diving.
call.
And and in and in those days we were using uh,
Yes, it is. Cool.
50
Awesome.
cube 50 cubic foot double scuba tanks made in Germany, steel tanks, and they had these strange double hose regulators, which you'd have seen if you watched the early Cousteau movies. So that was what I trained on. And after the 8 weeks, did a bit of a test where we had to do our various skills underwater in the pool. And in 1962, I became a qualified diver, got a little certificate from the Underwater Club, and straight away started exploring the islands of coast of northern New Zealand. And you can see a picture, I'm on the left there, in the early days of diving in New Zealand. The first thing I did was spend all my life savings of £70 of 100, that's $140 for those that don't realise that, on a wetsuit and scuba gear. And I also bought a spear gun, and although I speared a few fish and grabbed some crayfish in my time, my main interest was the marine life that I was finding on these exciting dives. In those days, we'd just go out in a boat together and just everyone would just leap in the water and just go off and do their own thing. My thing was just looking at marine life and finding exciting new things. And I very quickly found that when I started to find out what some of these things were, that very little was known about such things in those days. I had the experience of taking something that I'd collected up to the Auckland Museum, and the curator, the appropriate curator, didn't know what it was. So it was a really exciting time. And in fact, I discovered my first new species, which was a nudibranch in 1965. Went on to discover quite a few new species of fish, including this. You can see in the photo there the crimson cleaner fish, which is now called Suizichthys aylingi, which I first found at the Poor Knights Islands in 1966. But then Avril arrived at the marine lab where I was working back in 1975 to do her PhD on sponge biology. And we had lots of working and playing together with our fellow students. And one thing led to another, and we were married in 1977. This photo was actually taken on our wedding day. Avril, we're walking down to downtown Auckland to the registry office to get married. And then after we'd finished our PhDs, we moved to Australia in 1979 and eventually settled near the Daintree River and started diving on the Great Barrier Reef. And we set up a partnership, consulting partnership called Sea Research. And although I'm giving this talk, Avril has, of course, been involved intimately with all the work that we've done over the years and all the development work that we've done. And what I'm doing today is not really a serious how-to talk, but rather a light-hearted look at the twists and turns of developing these underwater count methods. Sorry. And I've put in here on the light-hearted idea, I've put in here a few light-hearted paintings of a not so light-hearted event where I encountered a remora underwater. We used to have I used to have zips in my wetsuit, fly zips in my wetsuit so that I didn't pee in my suit underwater. And one day I encountered a remora who took rather an interest in a private part of me and gave it a couple of sharp bites. So I still don't like remoras to this day. Now, back in the early 60s, when I did start diving, science underwater was really about just finding out what was there and describing it. I mean, we found lots of new stuff and it was very exciting. And all this early diving and development of count methods and stuff took place at the Marine Laboratory run by the University of Auckland at Goat Island near Leigh. And here's, you can see in the right-hand picture there, Goat Island with the Marine Lab on the point opposite it. And here's me back in those days, early days of diving at the Marine Lab. So we started trying to measure and count things underwater back in the late 60s and early 70s. And Barry Russell, who was a fellow student at Leigh doing his MSc on fish community around Goat Island and mainly looking at habitat structure that the fish were using and feeding and growth and things. He decided to try and estimate fish numbers and asked me for help. And we decided on a transect size of 30 by 10 meters, and we'd mark it out with rope, or it was Barry's idea to mark it out with rope. So we had this oblong of rope, 30 by 10 meters, with another rope down the middle, divided into two 5 meter strips. And we then tried to lay that out underwater so that we could search it for fishes. Well, you can imagine that was a total nightmare trying to get this rope square laid out on the bottom. It took us over an hour of snorkeling around in about 5 meters of water to eventually lay this thing out. We got a bit faster over time, but it took us a week or so to make 5 counts, and we each did the count and found that it was actually quite a good technique. It worked pretty well, uh, and we got results that were fairly comparable between the two of us. Then once Avril arrived on the scene and we were working and diving together regularly, we were figuring out how to do things underwater as we went along. He see us back in those days. I had a bit more hair then. Uh, and both needed to count benthic feeding fishes for our PhDs. And so we decided to take Barry's method and make it easier and quicker. So the first thing we did was ditch that bloody rope and used waterproof tape. The tapes were 50 meters long, so we decided on 50-meter long counts and that we'd run the tape through the middle of the transect and then estimate a 5 meter strip on each side of the tape. And at this stage, we'd actually learned about replication from emerging ecologists in America, so we decided to do 5 random replicates at each site, and that we'd restrict those 5 sites to a single habitat to try and get our variability down. So did it work? Well, the trials showed that the width estimation of the transects worked really well, and it was quite accurate. You could quite quickly learn what 5 meters was. We'd run a tape out and check out each transect. And we also found that our length estimations of the fishes was pretty accurate. What we'd do in those days, we'd find a fish that was just sitting on the bottom or very close to the bottom and estimate its length and then go and measure its footprint on the bottom, chivvy it out of the way, and found that we got pretty good at that after a while too. So I ended up using this fish count method between 1975 and 1978, making a baseline survey of what was the world's first no-take reserve at Goat Island in New Zealand, and ended up surveying a total of 30 sites and 6 different habitats. And we went back to a lot of these sites many times over the 3 years of the baseline survey that I was doing. It was made easier over there, of course, because we were only dealing with about 20 species of benthic fish. We didn't count the tiny blennies and secretive nocturnal things, and we didn't count pelagic species. So we only were dealing with about 20 species. And remarkably, and we wouldn't have said this before we actually did the counts, but the commonest fish by far in the marine reserve was the goatfish. You can see on the left there, and that was really common. The leather jacket over on the right here was also pretty common. And we also had what was called the blue cod there, a parapercus in the middle, which we nicknamed the grumpfish for obvious reasons. So this worked really well, we found. Doing these fish counts underwater was a successful way of estimating fish numbers. And you can see here, this is a map on the left there of the Goat Island area, all the marine habitats. And those circles are where I did fish counts on multiple occasions over the 3-year survey. And on the right here is my typewritten uh, table of mean abundance of the fish in these different habitats that we surveyed. In those days, you didn't have computers. It was all done with uh, typewriters and calculators and things like that. Now, it's not relevant to this story, but at the same time, we developed the line intercept method to estimate the percentage cover of encrusting organisms that we were doing for our PhD stuff. Um, and when we came to Australia, we trialed that same line intercept method to look at the percentage cover of corals and found that it worked really well, and ended up deciding on using 20-meter long transects to do that. And we used that for many years, uh, starting with the surveys on Cape Tribulation fringing reefs north of Cairns, where we were monitoring sediment runoff. Here I am back in those days setting up one of our first permanent transects underwater. But meanwhile, in Australia, Wendy Craik, who was the research and monitoring officer, just the single research and monitoring officer at the early Marine Park Authority, decided they needed to count, as the marine park was mainly about protecting fish species and coral trout was the major target fish, decided they needed a method to count coral trout numbers. And so she convened a couple of workshops, which they did at Heron Island down on the southern Barrier Reef. And a number of people went along. This was just before we came over to Australia. And the workshop ended up proposing that they use hectare counts to estimate coral trout numbers. And these counts were going to be 150 meters long and 67 meters wide. And they do these counts by running out a 150-meter rope along the edge of the reef, then run a 65-meter rope at right angles down the slope, and the divers would then swim a zigzag course up and down the reef counting coral trout numbers. Now, this workshop team included a number of people, including Barry Russell, who's still a good friend of mine, and I think some of them should have known a bit better than proposing what they did. But can you try and imagine it? The sort of scheme that they were proposing using for these counts, where you'd run this 150-meter line along the edge of the reef, and it's not normally nice and straight like this, and then the 65-meter rope at right angles, and then swim this zigzag search path up and down the reef slope, counting coral trout. And this was the only fish species you were counting in these counts. Here's some of the common coral trout that we were trying to count with them. So the initial idea was that these counts would be made on the northeast face of each reef, similar to where AIM sites their long-term monitoring program counts today. And at that stage, the Capricorn Bunker reefs at the south end of the Great Barrier Reef were the first reefs to be gazetted as part of the marine park. And Queensland Marine Parks used this method in the early 1980s to do counts in the Capricorn bunkers. And then when we came over to Australia and I went and spoke to Wendy, she wanted me to do some of these hectare counts as part of the work we were doing, and that I should use these hectare counts. So we started doing them on the Great Barrier Reef in early 1980. So did this whole method work? Well, there were a lot of problems with it. Uh, for a start, the northeast side of the reef where we were meant to do these counts was pretty exposed usually, and conditions were often rough. So you were trying to lay out these ropes and anchor your boat and safely do the counts on the rough part of the reef. But also the main problem was laying out those ropes. It was just a nightmare. Imagine having 150 meters of thin rope in the boat and trying to lay it out on the bottom along the edge of the reef in a small bouncing boat, and then to run another 65-meter line down the slope at the end of that. Uh, we ended up, after quite a lot of trial and error, figuring out a way where we could actually do this without too much hassle, but it was just a nightmare. And we also found that on this northeast face, when you'd swum out 67 meters, you were often in 20 or 30 meters of water. And then you were trying to zigzag up and down the slope. And a lot of people had trouble clearing their ears after one or two times up and down the slope. And we also, of course, found that it was very hard keeping track of where you were and which bits of the reef you'd searched, and especially when the underwater viz was less than 15 meters or the slope was irregular. And of course, as those of you who have dived regularly on the reef know, that the water is often less than 15 meters viz. And we also found that you couldn't do more than one count a day, really, because you were ending up with so much bottom time in deep water. So what do we do about these problems? Well, we proposed changing it to the back reef rather than the northeast face. And we did a few trials and found that there was no difference in coral trout abundance in those two habitats. So we changed to the back reef, protected back reef, where you could always do them and where it was calmer and easier to lay out the ropes. And we improved the logistics by running the rope through the middle of the count area, so about 30 meters from the reef edge. And then the two divers would search parallel 17-meter strips each side of that line, starting on the deep side and then going up and along the shallow side. But we found that it was still, even though you were only searching a 17-meter wide strip each diver, still found it was really difficult to keep track of where you were and what had been done and where the other diver was and where the rope was. So it was still a nightmare logistically. Then in 1982, Howard Choke got me to help him doing some work at Lizard Island, and I persuaded Wendy to let me trial a few things. So I did hectare counts, and in the same area of reef, did some of my old 50 by 10 meter transect counts and counted coral trout, and predictably found that we were getting about twice the number of coral trout in the transect counts, or an estimate of twice what we were getting in the hectare counts. This was our modified hectare count method with the search paths going along the reef rather than up and down and the rope through the middle. Then in 1983, Wendy Craik at the Marine Park Authority approached us about uh, counting coral trout through the whole Cairns section on a lot of different reefs through the whole Cairns section of the marine park. It wasn't gazetted at that stage, and they wanted to find out fish numbers on a lot of the different reefs to improve their zoning plan. But they wanted us to use that hectare count method that the workshop had proposed. But I did persuade Wendy to let us use the 10 50 by 20 meter transect counts on each reef as well as the hectare counts, which was good. This was a big trip. It took us 54 days in a charter boat, and we surveyed 43 different reefs from near the coast out to the outer barrier. And this is just the idea of what we did. We did some of the hectare counts, which is that big dotted square, but we also did, running down the slope, we did some 50 by 20 meter transect counts through the same sort of habitat and did 10 of them scattered along about a kilometre of reef edge. Now you can imagine what we were like after 54 days at sea doing these surveys in all sorts of weather, We were pretty demented, the team of us after all that work. Here's Avril on the left there in that main photo, and me. And you might recognize Rick Brayley, who came and helped on those early counts. And behind him is Leslie Newman, who went on to become an expert in flatworms. What we did find from this big full-on 54-day trip was that we got the density estimates using those transect counts was 2.5 times higher than what we got in the hectare counts. And we also found that the hectare counts, as we well knew, were logistically really difficult and in fact impossible when the underwater vis was less than 10 meters. So what do we learn? Well, these transect counts gave us good estimates of coral trout density, and they let us look at the major drivers of coral trout abundance, such as cross-shelf position. And this is just a graph of the cross-shelf position from the coast on the left over to coral sea reefs on the right, and looking at the abundance of the different coral trout species across the shelf. And the black bars there are the common coral trout. The white is the coastal bar cheat trout, and the blue spot is the pink there. So you can see it let us get a really good handle on the what was driving coral trout abundance. So after those Cairns section surveys, the Marine Park Authority finally decided that we could ditch those hectare counts, which we were very relieved about. And between 1983 and 1989, we used groups of 10 50 by 20 metre transects to count coral trout and other fish species. We'd started to include more and more fish species in our counts, and we counted fish on more than 200 reefs all along the Great Barrier Reef, starting in the far north and then working down to the Capricorn bunkers at the south end. And these transects, as I showed in that little map before, they were run down the reef slope to try and cover the same depth range that was surveyed by the old hectares. But then in 1990, and for a few years there, we did detailed methodological studies with Bruce Mapstone's help to try and refine these methods still further. And we trialed a whole lot of different lengths and widths of transect at different depths. And we ended up settling on 5 replicate 50 by 5 metre transects at each survey site run parallel to the reef edge in about 5 to 10 metres depth. So this is a schematic just showing roughly how this compared with the old hectare counts. And from 1990 onwards, this was the new standard. Thank goodness. We were very relieved to get to what was a safe and easy methodology for counting fishes. And it was first used for the Bramble Reef replenishment surveys from 1991 to 98. Bramble Reef was a reef north of Townsville that was closed for 3.5 years to try and replenish fish stocks, especially coral trout. And the Marine Park Authority wanted us to monitor coral trout numbers from before they closed the reef right through the 3.5 year survey, through 3.5 year closure, and then for a year or so afterwards. This same method was also the whole basis of the effects of line fishing experiment fish counts, which was 36 reefs, 6 sites a reef over 10 years from 95 to 2005. And of course, as Danny well knows, this is the method used by AIMS for their long-term monitoring program. And we've used it for assessments of entire reef fish communities in many locations around the world since we first developed it. So how do we do this? Well, it took a while actually. The first survey that we did using this method. It took a while to sort of refine the technique. We ended up carrying 4 tapes between the two divers, and the tape laying diver would run the tape out behind the person who was counting the fish in an estimated 5 meter wide strip. And so towards the end of the transect, the tape laying diver would quickly swim past the counter to show that the end of the transect had been reached. And we'd then run out 3 tapes, leaving them on the bottom as we went, along one way from where the boat was anchored, leaving a gap between each transect. And then we'd come back with the tape layer, winding the tapes in behind the counter, who was then counting smaller fish in a narrow strip, a 1 meter strip along the tape. And then we'd run out 2 more tapes the other way, so we had our 5 replicates and repeat the whole thing. Now, this method was much easier and safer than any previous arrangement we'd been involved with. And this is just Avril's take on fish counting. This was a painting on a card she gave me years ago. And we never actually came across this, but those coral trout are pretty smart, so they might have been figuring things out. So here we are doing our fish counts underwater. On the right there is just the swimming along in front of the tape layer, and on the left coming back counting the smaller fishes. And this worked really well, that bramble reef monitoring that I talked about. Uh, we did 8 surveys over about 5 year period through the closure. And you can see on the graph on the left there, it's the bramble reef results. And this is adult coral trout, went from around 10 per hectare during the baseline up to well over 50 per hectare at the end of the closure, but then very rapidly dropped back down to around 10 after it had been opened again. This was quite an interesting project. But then in the mid 90s, these hectare counts wouldn't completely die. Howard Choate approached me about counting numbers of his favourite Bulbometapon, the bumphead parrotfish, and other big parrotfish on the outer shelf reefs where he was working on. And we decided that these things were too rare for the transect counts to really encounter them often enough. So we decided on a modified hectare count where we'd swim a 500-meter long transect, 20 meters wide, centered at a depth of around 10 meters. So you're covering the whole hectare count in that 500-meter strip. And how we do this is we'd find a good anchoring spot in the habitat we wanted to work in, and then use the GPS to run 500 meters up current from that. And then the counting divers would be chucked in the water. The boat would go back and anchor where they'd decided on, and the divers would swim back to the boat at 500 meters, counting fish as they went. And this worked actually really well in clear water where there was a defined reef slope. And each count only took 40 or 45 minutes. And the whole idea was to count these guys, to count the big Bulbometapons, who were a bit rare for other methods. We also used the same hectare count in 2008 when the Marine Park Authority wanted us to look at reef shark numbers and other large predatory fish on a bunch of reefs off Townsville that were zoned different levels of protection. And this worked really well again, but you can see here the results. The blue reefs, the fished reefs, shark density was only around 1 per hectare. This is the all the reef sharks combined. But then on the green protected reefs, it stepped up to almost 3 per hectare. But then we found on the totally protected reefs that you weren't even allowed to go to, the preservation zones, was almost 6 sharks per hectare. We had a special permit to go and visit those reefs for that project. So what about sharks? Now that's a question we get all the time. Do you have problems with sharks? Are sharks dangerous when you're doing this work underwater? And we've certainly had a few dramas with sharks over the years, but the only life-threatening incident that we've had was not with a shark, but a crocodile. And as I think many of the people who are listening well know, on my 49th birthday, while we were doing fringing reef surveys at Cape Flattery, um, just near Lizard Island, I was attacked by about a 3.5 meter crocodile. So this was my 49th birthday present, was wrestling with a crocodile, and here's a few of Avril's pictures that she used to illustrate a book on my underwater escapades of this episode with the crocodile. It was about this long, about 3.5 meters long. And I ended up spending a week in hospital, had 3 operations to control the infection in my foot. But was back in the water after 5 weeks. And it took about a year for my 4 foot to recover completely. So this has all been an amazing experience. Avril and I, between us, worked out how to count and measure things underwater in New Zealand back in the mid-70s. And these methods have ended up being the basis of our whole career path over 45 years. And we're really grateful to have been involved with developing these techniques and using them for so many projects. But above all, it's been amazing to have worked with so many people, including people like Kath here and Danny, um, and Maya, and we've made lifelong friends in the whole process. And we still really enjoy getting out there and seeing what is going on in the coral reef ecosystem. And it's always really wonderful, especially on days like this, which unfortunately are few and far between. So thanks. Thanks especially to the mob at the Leigh Marine Lab back in the 1970s, including Jeff Jones, most of you know, and Howard Choate, for an unforgettable time and planting the seeds for all of this. Thanks also to Wendy Craik in those early days at the Marine Park Authority. It was her initial impetus that got us going on this. And thanks to her also for being willing to change paths when we decided those hectare counts weren't what they were meant to be. Thanks also to all the boat skippers and crew and dive assistants that have helped us over the years. But above all, I want to thank Avril. Without her, none of this would have been possible. So there you go.
Great talk, Tony. If you stop sharing your screen, we will go to questions.
There we go.
Well, I'm not sure how many people we've got, but it's certainly over 20. So that's the record, Tony. There's a lot of interest. Who'd like to ask the first question?
So,
thank you.
Really enjoyed your talk. What has been your favorite experience or favorite location after so long in so many places underwater?
Well, there's 2 places that are great. The front of the Outer Barrier Reef, up north, sort of north of Cairns. The front of the Outer Barrier is pretty good, but and that's where the water is usually clearest and where you're more likely to encounter something really interesting. But amazingly, some of my favorite places to dive are on the Pompey reefs around Hydrographer's Passage and further south, where you've got the big tides and where it's in big currents, like up to 10 knots of current through some of the reef passes, and where the fish populations and coral are just really rich and amazing. Quite often the water is not as clear as you're getting on those outer barrier reefs, but just amazing reefs, really difficult to get to and to dive on, but just amazing, as I'm sure Danny will attest.
Okay. Hi, Tony.
Hi, Kath. Lovely to
Hi,
see
and
you.
Avril. Yes, likewise. It's been a while.
Yes, yes.
I'll have to catch up. I do have a question, which is, I mean, over the long period of time that you've been researching the Great Barrier Reef, you would have seen a lot of change in terms of, I guess, resilience of the reef in different at different latitudes. I was just wondering if you wanted to provide a quick synopsis of how you see that, how you see the reef's health and resilience into the future.
Yeah, that's a question we get asked a lot. It's change. It changes is the answer to that. It changes all the time. If you go
Mm,
back to a place like we've been back to some places for well over 35 years, and in some cases over 40 years, going back to the same place time and time again, and it changes. I mean, it can be beautiful one year and awful the
mm,
next, and then it slowly comes back again. Um, there are certainly worrying signs. Uh, maybe I mean, there's always, right from back when we first started diving on the reef in the mid 70s, there's always change. But it does perhaps seem that there's more change going on now, and that but you can still find amazing places out there, and the reefs come back really quickly. I don't know what's going to happen with this with the bleaching. I mean, that bleaching is a
mm,
worry when you get large, um, long-lived corals bleaching and dying, like some of the parietes we've seen. That is a bit of a worry. So I don't really know what the future's going to hold. I mean, we've just seen our favourite place at Snapper Island uh, mostly completely destroyed by a one in a millennial flood event, which would have put 10-meter depth of fresh water around the island for days on end and just
mm,
completely destroyed everything on the southern reefs of the island, which had corals that were hundreds of years old on it. So it was
mm,
definitely something that we've never seen before. So yeah, I could talk on and on about this, but yeah,
mm.
basically change. It changes. If you
Change.
don't like what you see, wait a few years.
Yeah, sure. I guess with increasing rain events, there'll be increasing sediment going out onto the reef. So I guess that would probably become a more commonplace occurrence as well.
Yeah, yeah.
Yep. Thanks, Tony.
Thanks, Kath. Good to see you.
Dan,
Yeah, likewise.
then John.
Thanks, Tony. That was great. There's some of that history I knew, but some of the history of exactly how the method was developed, I didn't know. And it'd be great if I could get you to come and do that talk for the LTMP, actually. I think they'd all really, really love to hear it. I don't see any of them here, so but we can talk about that later. I do have a question though. I do remember your pink zone study. Um, which was really, really cool to see. And we've been talking about, because we do have sites on pink zones that we're allowed to go in and survey every year with the method. Um, and I've sort of been pushing to analyze the data a little bit more and maybe even add more pink zones just for 1 year, just to see whether leaving these little places completely alone makes a bigger difference than just not fishing in them. What's your feeling from, having done that pink zone study about just the general gist of the fish community in pink zones? Do you think it's worth pursuing?
Yeah, I think it probably is. I think what's happening is it's not that people aren't going there, that's important. It's probably that it acts as a bigger deterrent than just the green zones. So people are less likely to go there. Having said that, we have seen fishing boats on pink zones occasionally in the past, and I'm sure it does occasionally happen. Um, yeah, I mean, I just showed the shark data there. There was also in my mind maybe because the sharks never saw divers, they were more curious and came around more often in the pink zone. But we also got the same pattern for coral trout, both species of coral trout. So I suspect that there was an actual effect on density. Yes, I'd really like to see some more pink zone work done. I think it would be really interesting to see. And I think that what it's showing is that we, if reefs are really protected, really, really protected, then you're going to get more of an effect than if occasionally people are getting in there and taking stuff. Because we all know that, you know, if if there's less fishing pressure on a reef, the fish are much easier to catch. Like they get something like 3 times the catch rate for the same effort. So they're much easier to catch, and a small amount of uh, illegal fishing is going to make a big impact. And we need these protected reefs. We need to build up uh, healthy numbers of big predators. Yeah, go for it.
John Tanzer, you had a
Thanks,
question?
Tony.
Thanks, Danny.
Yep. Hi, Tony. Thanks for that. That terrific. Wonderful.
Hi, John.
Certainly, I didn't realise, but I benefited from your getting that technique changed back in the mid 80s when we were doing the Capricorn Bunker group down
Oh, were you
there.
involved with that? Right.
Yeah,
Yeah.
with I was with
New
Cabrompa, but
Zealand.
Parks led it.
Yeah.
Sue, now I'm going to have to recall
Yeah.
names, but you'll know. But anyhow, it's I've long been a fan. This probably follows on a bit from Kath's and Daniella's question. I've always been interested when I'm diving to try and see the effects of zoning to see if they're visually able to be discerned. And of course, no one spent more time in the water than what you and Avril have done. So in the context of a blue reef, a yellow reef, and a green reef, not always easy to find in proximity to each other, but the short question is, do you notice a change in reef health and ecosystem function between the different zones? I mean, what's your informed reaction to that question, please?
I don't think you can notice an obvious difference in overall reef health. I mean, you can certainly see the difference in coral trout numbers and the numbers of some other fishing target species on a like some of the green blue reef comparisons we've done. We've had 10 times the number of adult trout on the protected reefs. So you can certainly notice that difference. Whether it's really hard because reefs are so variable anyway. That's one of the things all our work has showed us. Reefs are very variable, both in time and space. Um, because there's such variability anyway, I I couldn't say that I've seen a difference, an easily observable difference in overall reef health between protected and fished reefs. I
Yeah.
think some of the AIMS work has shown that there's um, more disease, more coral disease on fished reefs, uh, and there's also certainly more crown of thorns outbreaks on fished reefs. Some work we did with Kath actually in the Cairns section showed that we were getting almost twice the number of crown of thorn sea stars on the fished reefs and on the protected reefs. But no, I don't think I could say that I've ever noticed an obvious difference,
Mm. I mean,
apart
as you
from
say, there's so much,
just fish numbers.
yeah, so much variability. It's hard to get them
Yeah.
in proximity to each other and the same. Yep. Anyhow, enjoyed your talk. Thanks, mate. Ta.
Thanks, John.
We can take one or two more questions before we wrap. Who would like to jump in? Tony, I'll jump in. How many dives have you done, and how many species of fish can you use their Latin name in the Great Barrier Reef?
God, how many dives have I done? When they first brought in when they first made us have a commercial ticket for diving, which was, I think, back in 92 or something like that, for diving on the reef, for doing research work, we tried to figure it out. I've actually got dive logs from 1962 for all my dives up until I came to Australia. And then with Australian stuff, when we started working, I never really did individual dive logs, but I, knew from the projects that we did how many dives I'd done. We worked it out then. I'd done 6,500 hours underwater back in 1992. And so about probably, 7 or 8,000 dives then. And since then, I've certainly done, I mean, after that, there was all the bramble stuff and the effects of fishing stuff and all our fringing reef stuff. So, it's what I do now when I'm asked, I just say 12,000 plus dives. And as for the fishes, I don't know. For some reason, I'm hopeless with remembering people's names, but for fish names, they just lodge in there, and I still can just dredge up these names that I haven't used for years and years. There's, I don't know, hundreds and hundreds of reef fishes from all around the world, names lodged in my brain.
Final question from Rochelle.
My question was, you've had so much experience over the decades. What do you think will be most important for scientists, conservationists, and just any general person concerned about the reef to do or look out for in the coming decades?
Well, my contention has always been that the single most important thing is to get real protection from fishing on the reef. I mean, um, I've seen commercial boats in green zones a number of times over the years. As I said to Danny, I've seen boats fishing in pink zones, and we need to get real protection on these reefs. And I think that's incredibly important. It needs to be really fierce deterrents in place to keep people out. A multi-thousand-dollar fine um, for recreational people and confiscating the boat. They do it really well in New Zealand for any of these protection things. If you're caught breaking the rules, they just take your boat and you take your car and things like that if that's involved. So things like that would really make a big difference. Uh, yeah, the other thing is, I guess there's just too many of us. I mean, it's just you can't help but have impacts. And when the major ones are out of your control, like global warming, it's a bit difficult. But the biggest thing in my mind has always been we need real protection for these protected reefs. We need to, you know, get those fishermen out of it.
Thank you.
I know that Adam is a keen spear fisherman and so on, but I I have got and I used to be a keen spear fisherman myself for many years. But I eventually had killed so many fish for science that I decided that I'd had enough with that and I wouldn't kill anymore. But I think this whole idea that it's your right to go out there and drag fish out of the sea and kill them um, is just we've got to get over it. We're not hunter-gatherers anymore, although genetically we are.
Well, I think that's a great place to finish.